You are going to need a ruler protractor. I, every year, make plastic ones here. So if you don't have a ruler protractor, you'll get a chance in a bit to come up and get that. Let's just talk about vectors here. Okay? So, after this, you're going to know what a vector is. You'll be able to understand vector direction conventions and be able to draw a scale drawing of a vector. Okay? Vectors are everywhere in physics. When I pull them out in grade 12, they usually grow. Okay? They keep coming back to haunt you. It's like a bad burrito. You can write this down. It's entirely up to you. I'm going to talk about vectors. You write that. You do what you need to do so that you understand what a vector is. If that means writing stuff down, be my guest. If it means sitting back and just watching, be my guest. If it means sitting back and watching and then printing out the notes that I'm going to post to Schoology before 10:15, do that as well. Do what you need to do.
Do I need the first page? Oh no, okay.
A vector is simply an arrow that represents a vector quantity. What we're really teaching here is vector quantities. There are 4 vector quantities, which I will introduce you to in the near future, and the arrow just represents them. Two parts that are important. The length of the arrow represents the magnitude or size of the vector. Now, the word magnitude always gets people, so maybe highlight it or whatever, or make a mental note. Magnitude means size. How big is it? And the second thing that's important, that's what you needed the ruler for. The second thing that's important is the direction. The direction that the arrow points represents the direction of the vector quantity. And so we have to talk about direction today. I have a vector there. If I were to get out a ruler and measure it, where would I measure it from and to? Well, obviously you'd start there. Where would I go on the other end? Like to there, you mean?
Yeah.
Yeah, I actually have had a few students over the years that want to do that. Unfortunately, Graham, that's wrong. Yeah, don't do that. It actually goes to there. Right to the very tip. It's okay. You learned something, right? Make a mistake, no big deal. He was bold enough to try. Yeah, so don't do that. Sharp pencils are really good. Big, fat pencils that haven't been sharpened in 20 years don't work so good. Yeah, a little pointy one is much better. This might help you remember what a vector is. All right, so you need to know the difference between a scalar and a vector. Vector is simply something that has a direction with it, right? Oh yeah, let's go get a clicker. The answer is C. Uh-oh, I fooled you, didn't I? Lane, really? It's pretty strong language for this early in the morning. It's not speed, because speed is the scalar version of velocity, which I didn't tell you. It's a little bit of a trick. I apologize, but you'll remember it now. Momentum has a direction. Momentum. Density and volume are scalars, so is speed. So speed is scalar. Velocity is the word we use when we put the direction at the end. I apologize for being a bit of a jerk there. Which one of these do you think is a scalar? Doesn't have a direction. Gravitational field strength, density, magnetic field strength, or torque?
Too late now.
Too late now, Lane?
Graham.
How'd we do? Hopefully better?
Yes!
If you were paying real close attention, you would have noticed that density was there, wasn't it? Is that how you did it?
Yeah.
Gravitational field strength. Generally, the direction is down. Magnetic field strength is from north to south, usually. And torque is either a clockwise or counterclockwise direction kind of thing. Okay. Do not write all this down. Just let me talk to you about this. Seriously. If you really, really want to, you can write it down. But, well, there might be some more. Just relax. I just need to give you some sort of background stuff. Vectors are represented algebraically when you're talking about an expression, a mathematical expression in a textbook. It's usually a variable with an arrow over it, such as this one for velocity. Textbooks will show the full arrow. When you're hand drawing them, you would just go V, and you draw your sort of arrow like that. That indicates that it's a vector. You don't need to write that down. You just go, okay, yeah, it makes sense, right? I'm not going to test you on that. Okay. Again, don't need to write this down. You just need to listen and say, okay, yeah, that makes sense. When representing a vector graphically, in other words, when you're drawing them, you may move the vector any way you like as long as the length and the direction which it points remains the same. Those two things must remain the same. Okay? These two vectors shown below are considered equal even though they do not have the same starting points. This vector here, oh, they're two separate ones. Well, because they're two different ones. So this is vector x, and this is vector y, and as long as they are the same length and point in the same direction, they are considered equal, even though they don't start in the same point. And you might think, well, duh, but you'd be surprised how many times people have said to me, can I move the vector on the page when I add it? And the answer is absolutely. This is exactly the same kind of thing as me doing this. Are those equal numerically? They are, and does it matter whether the 2 is there, or there, or there, or if I add them, can I go like this? Or can I go like this? Yeah, it's just it's a model, a scientific model like we've been talking about, that represents the quantity 2. This arrow is a scientific model that represents the quantity 47 kilometers per hour at north 30 degrees east. It's just a more complicated one. So you can move them anywhere you want. That's what I'm saying. Now, you're probably wondering, because you know that units are important, right, Graham? Graham, how's like 100,000? Exactly. You want to know 100,000 what before you say yes or no, right? Units are important. What are the units for these vectors? It depends. Depends on what? Depends on the type of vector you're representing. For example, displacement would be measured in meters. Velocity would be in meters per second. Acceleration would be meters per second squared. Force vectors would be newtons and so on, right? So it's not that vectors have special units. It's the type of quantity that it is. You guys need a little wrestling break or what's going on?
What are those yellow things for the lesson?
Those are half marathon bib numbers. That was back when I was actually okay. Now we got to talk about direction here. We got to talk about direction. Don't worry, I'm not going to talk about the band.
What? One direction?
Yeah, I'm not going to talk about that.
Oh.
The direction. There's more than one direction. The direction of a vector can be measured in more than one way. Unfortunately. I'll give you the easiest one. This is the one you learned probably in grade 9 or 10. A man is following a scavenger hunt. He's to walk plus 35 and then minus 10. Do you need to write that down?
No.
These are wonderful examples of things you don't need to write down. I'm just building here, right? So plus 35 would be 35 to the right and then minus 10. 10 to the left, right? You don't need to write that down. That's like, okay, yeah, I got that, right? No big deal. That's one thing. Positive and negative, right? Positive, negative. That's all you need to know. Okay. Let's talk a little more complicated. This one, you might want to write down. Is this an example you might want to refer to?
Yes.
Yes. Of all the things that I've said, this is something that you should write down. Now, pilots actually know this. They actually do this. It's important to them. An airplane is traveling at 200 kilometers an hour at 40 degrees south of east. Let's just ignore this part right now. 40 degrees south of east. Okay, let's not worry about the length first. Let's worry about 40 degrees south of east. Of east. Now, I guess before we even get started with that, if you don't know this, you're in trouble. Never eat soggy wieners. Exactly. You'd be amazed at how many times I've seen these two backwards on tests. You can come up with whatever you want, Graham. Just make sure that north is up and east is right and south is down and west is to the left. If you need that on your cheat sheet, you put it on there. Okay, 40 degrees south of east. So I'm going towards south from east. And so my angle is going to be that one right there.
What's the angle of east would be 90?
We'll get to that. Hold on. You're getting ahead of me. So this is 40 degrees south of east. So you look which direction first? East, and then you go towards south. How far? 40 degrees. Does that make sense, Peter? Yeah? Okay, now the other way to describe that is instead of writing out 40 south of east, is to write it this way. East, 40 south. Most students prefer this method. Okay, because 40 south of east, you have to sort of like almost jump around, right? Like you got to go all the way to the end, east, then I'm going south, 40 degrees, right? It's almost backwards kind of, right? East 40 south makes more sense. East 40 towards south. Okay? Yeah? Now again, you're going to make mistakes with this. Just practice and get better at it, right? East 40 south. Now what does the 200 kilometers an hour mean? Well, that's about the length. Okay, we're going to talk about that. But first, let's do a clicker question.
Should we talk this down?
No, this is a little check to see if you know it. If you want to write it down as an example after you can. Which one of these is east 30 north? It's 50-50, isn't it? Always pick C, right?
Can you pick A and B?
I don't think so. And no, you can't. Which one is east 30 north?
Well, hang on.
Let them think.
Yeah. I thought it's north of east.
30 degrees north of east
East.
or east 30 north. Those are the same.
What is it? A, B. Is it B? Yeah. Okay, I'm going to click B then. If you're wrong,
I put A.
Think, you guys.
Put A.
Oh, man.
Yeah.
put A.
You didn't realize he was telling you to pick the wrong one.
Yeah.
Come on, Billy. Think for yourself now. 30 degrees north of east. This is east. We are going
North.
30 degrees towards north, or east 30 north. East 30 north. You always have to have one of the four, north, east, south, or west, as that first thing, right? Whenever you draw these, there's always going to be one line that's either straight across or straight up and down, right? I'll give you a chance. Oh, no. We'll do another one. Okay, now, a couple people have talked to me, said something about heading, or made reference to it, right? This is what pilots actually do. This mumbo-jumbo is what physics teachers do. This is what pilots and navigators on ships actually do. Okay? It's called the bearing method or the heading method. A sailboat is moving at a bearing of 210. This assumes that 000 is north and it revolves clockwise. You will want to write this down. This is important. North, east, south, and west. I got to move the whole thing over because I ran out of room. Okay? North is 000. Generally, we use three numbers. I like to use the convention of putting them in square brackets, but I think that's just a Bennett thing. We're moving clockwise. So this east is going to be 90 or 090. South is going to be 180. And west is going to be 270. And I've never checked this out before. I've been told that the runways at airports are numbered by the direction that they point. How could we confirm that now with today's technology? Yeah. Well, what would be the best way to do it? We could go for a field trip, I guess, or we could just do a Google map for... If I Google Earth for Winnipeg, or Google Map, I guess, not Google Earth. Yeah. Come on. Did I press enter?
There you go.
Mostly cloudy.
I just want to go there. Can you see the airport from here?
Yeah.
Holy. Someone's streaming audio somewhere. Okay, well, we'll come back to that. Holy moly, okay, well. Okay, so a bearing of 210 would be which direction? 210 would be like that, and you're right, that angle there would be 30 degrees. Does that make sense? Right? And, okay, Billy, 210, how would I write that out with the other method? If that's that angle right there, that would be south 30 west, exactly. South 30 west is equivalent to 210, right? If this was a runway, I think they would call it runway 21, I think. They just drop off the right? The 21 tells the pilot that it's which direction that runway is pointing. So when they're coming in, they know which direction to look for the runway. Oh, there it is there. I think that's what they do. That's what I've been told. We're going to try to find out. Here we go. Okay, so north, right? This way, right? So let's just see if we can see. I'm going to have to drop a little dude in there. Can I not just go like...
I think you can just zoom in and just magically go.
Can I not... Where do I go for like, satellite view?
That's where you gotta drop the little guy in.
You got to drop a dude in there to get satellite view?
Golden boy.
There should be a golden.
I dropped him right in the middle of everything.
There's no dude. Here? This sucks. Okay, I'm going on. Okay, here's your question. Here's your question.
Which vector is
Which vector is
at
at a bearing of 300 degrees?
Let's go today. It could be the last one. There you go.
Don't listen to... Do it yourself, man. Oh, everyone's finished. Okay, good. Yay! Correct answer is D. 300, remember? 0, 90, 180, 270. 300, that would be west, 30 north, wouldn't it? Right? All good, right? Okay, let's talk about scale drawings now. Scale drawings are often used to represent vectors graphically. For example, 300 newtons down could be shown as, don't write this, just watch, okay? 300 newtons. For a scale diagram, you must have a scale. You don't know how frustrating this is to me. It's a pet peeve. The scale must begin with 1 centimeter equals. You are saying 1 centimeter on this piece of paper is equal to something like 50 newtons. Always, always, always start with 1 centimeter equals. So my vector would be straight down. I'm not going to worry about the direction here. And how long would it have to be? 300 newtons. 1 centimeter equals 50 newtons. 6 centimeters long, right? This would have to be a 6 centimeter long vector. Right? If you want to write that down, you can, but I think most people, okay, yeah, I get that, right? You've done that sort of thing before. You got to combine the direction with the magnitude. Okay, take a few minutes while I try to find that Google Map picture. I want you to draw scale drawings of the following. I have scissors, I have rulers, I have protractors up here. If you take one, please keep it, stick it in a hole punch it, stick it in your binder, put it someplace safe. Hang on to it. Go. 25 kilometers, so you would use a scale like 1 centimeter equals 1?
5.
5.
You gotta make your own scale.
Right? You can't come up with your own scale? So your vector would have to be 5 centimeters long, right?
Okay.
So we've started with our scale. You have to come up with this. If you said 1 centimeter equals 10 kilometers, would that be okay?
Yeah.
Absolutely. Okay, it's entirely up to you.
1 millimeter equals 1 kilometer.
That's a bad scale.
Will.
1 millimeter is 1 kilometer. So what would that mean? That would be 1 centimeter would be 10. That'd be the same as this, wouldn't it? Yeah.
I got it.
Okay. Generally, there's 2 or 3 sort of better answers for the scale, right? All right. So we're going to go 30 degrees west of north. Let me get my ruler and protractor out here.
I lost it.
It's real hard for me to do this up here, by the way.
I could just use like, I could just draw it like roughly.
Ruler, protractor. Okay, so I want west of north. So I'm going to draw a straight line that's north. We call that our reference line. If you want to label it with a little n, that's fine. Okay, now it's west of north. So I got to go towards the west 30 degrees, right? So mark your angle first.
Turn it like that.
So I'm going to go something like this. And now my protractor, this is a goofy thing here, right? So 90, I gotta go 30, so that should be 1. Yeah, I don't like that. Where's the other compass? No, that's not what I want. Put away. That's the one I want. There, okay, this is better. Okay, so 30 degrees, right? We'll put it on there like that. No. I don't want to rotate it. Just want to move it. There we go. Okay, 30 degrees. All right, so you're going to go here. You're going to go 0, 10, 20, 30. Make a little mark there at 30 degrees. Right? Get rid of the protractor. Bring in the ruler. Again, you can see what a challenge it is up here. Okay, that actually brings out a good point, Lane, is how close is close enough? Now I got to go 25 kilometers, so I got to go, I'm going this one, 1 centimeter equals 5, so I got to go 5 centimeters.
That one has to be 5 centimeters.
This one has to be 5 centimeters.
That's my ruler.
Now, Lane brings up a very good point, is how close is close enough? Well, when this used to be on the provincial math exam, the rule was this, plus or minus 3 millimeters. So if this is supposed to be 5 centimeters long, you could be anywhere from 5.3 all the way down to 4.7 centimeters. That's a pretty wide range. If you got 4.6, you're a bad ruler user.
Okay?
I very rarely see people that are off by 3 or 4 millimeters. If they're off by a lot. Right? If you're out by a little bit, it's fine. The other rule is plus or minus 3 degrees. If it's supposed to be 30 degrees, that means you could be anywhere from 27 to 33. Okay? So for tomorrow, I'm going to ask that you have those 3 done.
So which line has to be,
The one.
The one with the actual arrowhead on it. This is just the reference line.
So how would you measure on your ruler with like newtons and meters per second?
You would have something like okay, let's do the next one.
So what
15 meters per second, your scale is going to be 1 centimeter equals 3 meters per second. This one, it's going to be 1 centimeter equals like 15 newtons.
Is for like handed?
This just check. No, this just check.
North of east.
Okay. Try those 3 for tomorrow, and then we'll have a look at them.
So that's north and east then?
This is north 12 east, so that's actually east of north.
Yeah, so it's always.
Stop and really read it carefully. Yeah.
Well, then the other one would have been west and north.
This says west of north. This says north 12 east, right? Yeah. Watch out.